Motion practice test, page 2. How is velocity different from speed? Speed is just how fast something goes. Velocity tells you the speed and the direction. So velocity would be, I'm going 50 miles per hour to the north. Speed would be, I'm going 50 miles per hour. Or a really relevant example on this quiz would be, you throw a ball up in the air and it falls back down. When you throw it up, the speed might be 50 miles per hour. If so, and it's in free fall, it's going to come back down and the speed when it lands is going to be the same, 50 miles per hour. What's different is the velocity. Here it's going 50 miles per hour upward. Here it's 50 miles per hour downward. So we might call that velocity negative 50 miles per hour and this positive. But the speed's the same. Got these two graphs on the right. The question is, which one shows accelerated motion? And accelerated motion just means there's acceleration, and acceleration is a change in velocity. And velocity is how fast you cover, well, what I'm defining here is speed, but in this case, we're not worried about direction, really. Yeah, I guess we are. Anyway, velocity is basically how fast you cover a certain distance, how fast you travel a specific distance. So in this one, for every 2 seconds, so let's see, 2 seconds of time, this person goes from almost 10 meters away to almost 8. So they're moving from this position to that position. They're traveling about 2 meters in 2 seconds. Over this next 2 seconds, from 2 to 4, they're going from almost 8 down to almost 6. So again, they traveled a distance of 2 meters. Last couple of seconds, from 8 to 10 seconds, they went from almost 2 down to right around 0. So this is a straight line. I guess I could have just said it's a straight line, therefore we know that they're moving at a constant velocity. But the reason straight lines are constant velocity is because straight lines show you that for every amount of time, the change in distance is the same. What this one shows a curve, and any distance versus time graph that's curved, either curved down or curved up, that shows acceleration. So really, I was wordy there, but to answer this, if you're looking for acceleration, look for a curved graph. If you're looking for constant velocity, look for a straight line. But this part asks you, explain why this shows acceleration. So what I just did is explain why that did not. Now I'll talk about this one. I'll read this. This is pretty good. Curve B shows that as time goes by, a greater distance is traveled during each second. I circled that because that would be a fine answer. You could just stop there. Now I'm going to explain it even better. I gave an example here. For example, less than 1 meter is traveled in the first 2 seconds. So from this time to this time, somebody went from a little over 9 meters to just a little tiny bit under 9 meters. From here to here. That's a very small distance. From there to there. But during the last 2 seconds, somebody went from here, that's 4 meters, down to 0. So somebody traveled 4 meters during the last 2 seconds. They didn't travel very much here. They traveled a lot more there in equal amounts of time. So they're getting, there's a change in velocity. So there is acceleration. Okay, these are tricky. I think I'll probably give you, either take these off entirely, or I'll give you some more practice with actual numbers on here, but might as well go over them anyway. I'm going to get a clean one. So let me fix this. I mentioned in my classes that I messed up on that. This should be going down. All right. So what you do is you start with a graph of distance versus time. And you can do it different ways, but let's just think back to when somebody was walking in front of a motion sensor. In order to make a graph like this, you put the motion sensor in front of you, you sort of look at it, and then you walk away from it at a constant rate. If you walked away and got faster, it would curve up. If you walked away and got slower, it would curve down. So this is walking away at a constant rate. And on all these graphing exercises we do, if this is distance starts at 0, goes to 10, I'll put 5 in here just for the heck of it. The higher up you go, that's a positive distance. So if let me put time in here too. 1, 2, 3, 4, 5. If you go like this, that line that's pretty fast. That's really steep. The steeper you're going, the faster you're going. This is a positive velocity, and the reason it's positive is because velocity is change in distance divided by change in time. The change in distance is 0 to 10, and the change in time, it goes from 0 to 2 is plus 2. 10 divided by 2 is 5. Now if you had the opposite thing, I'll just draw this now, and I'll do the velocity of that segment. So this is the velocity of the second segment. The distance starts at 10 right here, and then the distance goes down to 0, so the change in distance, you lose 10, so that's negative 10. We're going to divide it by change in time. The change in time starts at 2, goes to 4, so it changes by 2, plus 2. Negative 10 divided by 2 is negative 5. So downward means a negative velocity, upward means a positive velocity. Walking away from the sensor is positive, walking toward the sensor is like walking backward, and a negative velocity. So just summing up all that, straight line means same velocity, an upward line means away from the sensor, a positive velocity. I'll write that, positive and constant v. So now I'm going to look for a graph down here that shows me a positive constant velocity. These are my velocity graphs. This one, the velocity is in this negative range the whole time, and it's not constant, it's going down. That's not it. Here the velocity stays the same, but it's in the negative range. Here the velocity stays the same, it's in the positive range. So that's the one. The velocity graph is C. Now I've got to figure out which acceleration graph goes with this. So there's a hard way and an easy way. I don't know. I think it's two easy ways. Remember, if you think back to making these graphs, if you have a graph like this, that means you're not accelerating. There's no acceleration. If there were acceleration, that would be like a curve up if you sped up, or curve down if you slowed down. So we just need to look for an acceleration graph that shows none. This shows a negative acceleration. This shows a positive acceleration. Both of them stay the same the whole time. This one shows no acceleration. So that's C also. That's a really tricky one. Let me come back to that one. In the future, if I make one like that, it's going to look like this. I might give you that. I wouldn't do this to you. That's kind of evil. Let me go to this one. So this looks kind of like the reverse of that. It's a straight line. So if you wanted to do this, you'd stand a little bit away from the sensor and you'd walk back toward it at a constant rate. You wouldn't speed up, or sorry, yeah, if you sped up, that would happen. If you slowed down, that would happen, because you're walking backward. Anyway, you get a distance away, walk back to the sensor at a constant rate. So walking back to the sensor, that means you've got a negative velocity. You're walking backward. Negative v, and it's constant. Downhill means negative, uphill means positive. So we just need to look for one of these three graphs that shows us a constant negative velocity. Here the velocity goes up, here the velocity stays the same. It's constant, but it's positive. And here the velocity is negative and constant. It stays the same the whole time. So that's graph B. Easy way to do this again. Remember, if you wanted to walk like this, you would just walk toward the sensor at a constant rate. You wouldn't make this graph curve at all. So constant rate means there's no acceleration here. So that means it's got to be this graph. That's the acceleration graph, the one with zero acceleration the whole time. The other way to do it is to look at this graph and say velocity stays the same, no acceleration. That leads us to here. Last, imagine yourself in front of a sensor trying to make this graph. You'd walk away and you get faster and faster and faster. So you're accelerating, so we're going to look for one with an acceleration. Plus you're going away from the sensor, so it's positive. Your velocity is always positive. Positive velocity and acceleration. Speeding up. So first, positive velocity. The only one that has a positive velocity that's actually increasing is this one. Here the velocity starts at 0, it gets faster and faster and faster. It's positive the whole time. This shows constant velocity, constant velocity. Here the velocity is dropping, so that wouldn't work because this is accelerating. So that's got to be the answer. Graph for that, the one, if velocity is going up, then velocity is being added. Adding velocity means there's a positive acceleration. So here we have a positive acceleration the whole time. Not that one, because that's negative acceleration. That would be slowing down. So this is B. Okay, first, I'm not going to give you any of these unless I somehow make them less tricky. So I'm not sure they'll be on the test at all. Even if I make them less tricky, I don't think I'll ever give you one like this. But I'm going to go over it anyway. So what we have here is somebody standing away from the sensor and they're walking back toward it, and they're actually walking faster. So their speed is picking up. They're speeding up, speeding up, speeding up. The weird thing is that the velocity is going to be decreasing, because if you walk backward faster and faster, backward motion is negative velocity. So walking backward means it's negative, walking backward faster means it's more negative. So that means your velocity is getting lower and lower and lower, which is kind of weird because you're going faster and faster. So let me anyway, that's the one right there. We want to, it's one where just the curve alone, the fact that it's curving down instead of curving up like this, you can figure out the acceleration graph from that. A downward curve means deceleration or slowing down. An upward curve is acceleration. So if I made it like this would also be deceleration. It's kind of curving down. Like this, it's curving up. That's acceleration. If I did it like this, call that an upward curve too. That's acceleration. So deceleration, deceleration. The only one that shows deceleration, which is decreasing velocity, is A. And then the acceleration graph, if the velocity is going down, then we have negative acceleration. So that's also going to be A. Boy, I feel like I've talked a lot and not made a whole lot of sense on those, but I hope that helps.